Hi everyone, and welcome back to Commitmas, the last night of Commitmas 2015, actually. And tonight we have Bringing It All Together with Anthony Chow at the Clouder and Beer. And a few quick notes, as always, before we start. Get in on the conversation by following at Commitmas or at vBrownbag or hashtag Commitmas, hashtag vBrownbag to ask us any questions or make any comments, etc., etc. You can find recorded episodes at bit.ly/commitmas2, the number 2. And of course, check out our GitHub repo, which you can probably Google, but just to make it official, it's at github.com/commitments/30 days of commitments 2015 with hyphens in between. All right, so without further ado, I will go ahead and make Anthony a presenter.
Okay, let's see, slideshow. See my screen?
Yep, you're there.
Okay, I'll start. Okay, good evening and welcome to Commitmas. My name is Anthony Chow. It's my privilege to present at vBrownbag. Well, we have learned a lot about GitHub this past month. Yesterday, we also learned how to contribute to open source. Today, we're going to wrap it up with Introduction to Go. This is just an introduction. While Go is considered a simple language, there's so much to talk about, especially some of its advanced features. Today, we're just going to look at the basics and hopefully give you a jump start, motivate, or arouse your interest to look deeper into this language and to contribute to any open source project that is written in Go. Docker is written in Go. Well, I just realized you only see my screen and not my face. So I don't have to worry about smiling, and I don't have to look into your eye to make personal contact.
That's right. You could even be presenting in your underwear if you wanted to be.
Well, what do you see on this slide? For me, I see a happy picture. And two things in this picture. Actually, this is the upper right hand corner is what I'm referring to. I see two things that I like very much. The characters are all very happy, and I see food. And after all, these are the two things that I've been pursuing all this time, and happy working environment, and ability and something to provide my family with food. So this is what got me started to look into Go. Another reason that I look into Go is that somehow we need to jump out of our comfort zone and learn something new or different so that we'll be able to stay current, to keep up with the fast-paced IT advancements. So do you have a reason to look into this language? And here on the slide, I list a few reasons. I hope some of them may hit you. Okay, next one. In general, we do not need to know about the history of the programming language, but for Go it is important because this dictates some of its features and design decisions. Go, as you can see in the slide, is to address a specific problem that happens in Google's software development and deployment problems. Google's infrastructure is huge, and some of the software that runs in this infrastructure is also huge. Even building a software image can take up to 45 minutes. Imagine there's a one-line change to a critical bug that needs to be deployed immediately. The developer has to take 45 minutes to build, make a change, and then go through testing. The turnaround time is just too long. So Google needs something very efficient and scalable and productive. This history of Go dictates the syntax and some of the features. Go was created by Google, again, in response to the problem to see a software development and deployment problem. It was just taking too long, and Google needs something to speed up the development and deployment time. Rob Pipe is one of the original designers of Go at Google, and he summarized Go as a compiled, concurrent, garbage collected, statically typed language developed at Google around 2007 for efficiency, scalable, and productivity. And I think these 16 words summarize Go in very precise and cleverly. When we say compile, that means an executable is generated to run instead of using an interpreter like Python, or for Java's case, using a JVM to run the code. And this is faster in execution. One good analogy that I can think of is running a virtual machine on ESXi versus running the virtual machine on a workstation. Running in workstation is just like an interpreted language. For concurrency, we can see Go, we're famous for concurrency. And this is to take advantage of the multi-processor of the modern hardware for concurrent instruction execution. I read somewhere in the web, I'm not sure where, I couldn't even find it again, is that for the same instruction, with using a simple for loop, it takes 42 milliseconds to complete. But it's written, well, the simple for loop is also in Go language. But if using concurrency, it only takes 14 milliseconds to complete the same task. So we can tell with concurrency, efficiency is indeed a good feature for Go. Another a special feature for Go is garbage collected. This feature eliminates the needs for the developer to write code for memory management. Well, it is a very attractive feature for me because I don't have to worry about a memory allocation and deallocation. And especially for concurrency, memory management can be a very big problem. But if the language can take care of it, that would be great news for us. Another nice feature about Go on memory management is that the stack is handled also automatically if there is no stack overflow. If the stack is not big enough, Go, since release 1.5 will allocate a new stack for you, and so that there will be no stack overflow problem. Statically type is another feature, is that the type in Go, let's say the variable, if we declare it as an integer, you cannot assign a string, whereas in Python you can do that. Well, this is very important because at the compilation time, the language itself, the compiler will check for this type checking, and if it is wrong, then it will issue an error, and you cannot be able to compile it as the image. This is important because this forced developer to handle the variable type more carefully. That means we can write cleaner programs. We will go into more specific with this later on in the demo. Besides rough pipe's definition, one thing I've learned about Go is that it's very developer-friendly. I've listed a few things about how it can be developer-friendly. But let's go into, let me show you something in demo. This is a section of code that I see in production. Do you see anything wrong with this section of code? It's very compact, as in C, and it's very precise too. It works, but there is a problem. Debug is very difficult with this function. There is no traceability or any record about if something goes wrong, about something wrong if the if case. It just fell through. I had a customer in Asia that demand line-by-line analysis of the production problem that we see at the network. Then if something happens in this section of the code, there is no way that can tell us how, or even remotely suggest that this section of the code has a problem, and we will not be able to debug. Debug is a big thing in software development, so be able to have the user-friendly is very important for us in writing the program. And also, if we look at Go, let's go back to the slide, is that it has built-in package for contemporary modules or functions, such as JSON, networking, or even web application. For this, we can easily use well-tested section of the code for our program so that we'll be safe. And also, for sure, this is a Go routine that we can take advantage of the multi-core hardware, and also this is because of the way Go is constructed, it has a rich ecosystem so that there are also other tools that help us to develop a Go program. The last thing is that what is the Go way? It is the way Go is constructed. It forces the developer to write the program in a specific way. It encourages simple programs, and it discourages people to write very sophisticated code which works and slick but is difficult to debug. For Go, it runs on Windows, Mac, and Linux. And you can see I copy from the website. These are the hardware that it can run on. This is good because once it is written, it can be compiled on different platforms, and it will just run. There's some Go terminologies. Why do we need to know about these terminologies? Because sometimes to know about these terminologies, we know about the language, and also when we read the compiler error or warnings, some of these specific terms might come up, and it will help us to know. For Go, everything is in the form of a package. And also for a block, it needs a delimiter that delimits the block. Unlike Python, that it's delimited by the block is determined by spaces. And there's also a scope. It is where the integer is how they define how they are referenced. And also there's a variable and a type. And on GitHub, I make a reference. I make a mistake. For type, I say type reference. Actually, there should be type to be value and reference. Reference, that means it's something with a pointer. We reference by the address of the variable. Some of the important features that highlights here is, again, we touch on is the memory management. Slice is a preferred way than an array. It's a dynamic array, and that's how we will look at this into when we go to the demo. And for map, it's similar to the dictionary or dic in Python. It's a key value store. This is important, especially for if you are familiar with container. The etcd is a distributed key value store system. So this is very handy. For composition, later on, this is something to do with object-oriented. We'll talk about if Go is object-oriented or not. And there's concurrency and interface. Interface is something important about Go that is not being talked about, and we will have a demo also on this so that we have a glimpse of how it works. And before we go into the demo, there is some basic programming terms so that we can cover a different variety of audience. For every program, there is a data declaration, there is an assignment, Ifthenelse, or iteration. We'll look into this. Well, look at some of the program. Okay, the demo time. Let's see, we'll go back here, and let's say Go is compiled, but also you can run it like this. Go run demo basic Go. Then this can be used to test our functions or programs. When we run this, you will see take some time. It's supposed to be faster, but I think this is the first time. So this is the output of the program. I have this on GitHub. If you download it and run it, you will see the same result. Okay. You can see some of this output, and we can look at the code and look at it. Look at the lines different. Let's see. So let's say vi demo. Is it? See, Go by packages, just like a library, and also import other packages. In this case, in line number 3, I imported the FMT package. So actually, I have written some comments so that this program is self-explanatory, but then we'll go through it. This is a function that we call main. We'll come back to this later. Now we start with the main. This is something we call the variable declarations. This is something we declare A as an integer. We could declare integer I and J as a string, and this is called a map. Just like index a value pair. We will say the map is 1 for January, 2 for February, and we'll look at the code we use. There's the slice. We declare the slice, the map for all the months in the year. And also we have a string 1. So this is one way to append the variable to the slides. This is what I put all the months here. And then this is the code illustration. Well, we see we have an assignment. We look at the length. The length is I forgot what length is, but it's assigned to a value I. And then let's go back to that later. And then one thing is that we can do triple assignments. The X and Y, you see X we have the value of 100 and Y we have the value of 200. And then I print it out. And this is part of some of the assignment. And then for the if then else, it's just the regular if. This is very interesting. This is called a null assignment. See, for check month index size, it returned 2 variables. This is something unique with Go. Cannot say with unique because I'm not sure about other languages. But this is some good features about Go is that it can return an error. If you look at it at the beginning, then this function check month index size, it is input as an integer and return 1 integer and an error. Actually, for this function, we don't need to return this integer, but this is for demonstration, is that I will return an integer and an error. The error is a specific string that will tell what's wrong with. So if we go back to the original program in C, if it is written in Go, we will be able to return this generic function message to the caller, so that it will not it will specifically know what the problem is. Before, if we only say, let's say if we go back to our C program, say demo.c, it's very hard to debug because we will not know what the problem is. We can say, have this inside function to log to a specific location, do a switch log, but if it is a generic library, we do not know what the caller is using for logging. And also, the call function, let's say for set root ID, this function has to agree with what the return value is, so that the caller function will know what's wrong. Instead, if it is in Go, we just return a string to specific set to specify what the problem is, and then let the caller handle. Because one same error, depending on the caller, we can choose to terminate the program, or we can choose to do something else. It's up to the caller function to decide what to do when there is a problem. So when we go back to this dash, that means we don't care about the value. It's just like a def no. If we change the program to something else and declare this, but let's say if we change this to RV, RV, if we do to this will not compile, because RV, even though it received the value from the call function, it's not being used in the program. The compiler will say, oh, this is an error. So this is something that unique, very good feature about Go is that we can declare it as a null, as an empty delimiter variable, so that the function we will not need to declare some unused function. And then I think one thing about array is that array has to be base 0. I learned it in the hard way at college. It cost me 1 grade. Instead of an A, I get a B because I index a bit, 0 bit. I call it as a first bit, and this cost me 1 grade, and I learned it the hard way. Good thing it's in college and it's not learned it on the job. So this is something about an array for sure. When we do programming, an array has to be base 0. So another thing is that when I'm trying to see, do you see anything wrong with this next set? Did you see anything wrong with this check from line 98 to 103? Actually, nothing wrong. Syntactically, it compiles, and it even gives us the right output. But then you will see the else case will never be true. You can never find a value of x. So sometimes programming is just like this. If you think you are programming one way, but actually the outcome might be different. See, because in this, if you write something like this, with a double not, if an or case, it's always a true. Never the else case will never happen. Another thing about programming is about iteration. There's one way, there's a standard for loop, just like a C-like for I equal to 6, and then the length you will just print out. And then next thing is about the range. Range is a specific keyword out in Go. It works on a slice. So string 1 is a slice, and we assign it. And if you look at the program, it runs. It will print out the. Actually, it's a string 1. I think is a map. It will print out all the years, and then. For this one, J is not initialized. J is not initialized because everything in Go is always initialized at 0. So you don't have to explicitly initialize a value. It's always it's very safe. You will not have some an unexpected value to a value that you declare. This is some basic about the Go program. And one big question about Go is that, is it object-oriented or not? Some said Go is object-oriented, and some said Go is not object-oriented. But if you look closer to that, in a way, it has the essence of a program-oriented or object-oriented programming, but it doesn't have the familiar names or way of handling. It has a specific way to handle object program. And something before, let's say I have another demo, and this is something similar to an object oriented program. Let's run that. It's called about the interface. Let's say go run demo interface go, and this is the output you see. Okay, this is some hypothetical case I come up with. So during Christmas season, last week, everyone worked an extra 40 hours, the developer and the operator. It prints out the name, the year of service, the skill, and the extra pay. You will see for the developer, the extra pay is 4,800, and for the operator, it is 14,000. We'll go look at the code demo. Interface. This is how we can use interface to do the magic. Because first of all, we have a declaration for a developer. We have the name, year of service, programming language, overtime rate, and then also over here, I think this is easier. In line 24 to 29, this is another structure for operator. It has name, year in service. Well, for operators, I think certification is more important. So we have this, and then also overtime rate. And now we have something called method. For now, I think we can always remember a method is a function with a receiver. At least this is how I am remembering what a method is. This is a method. It's called overtime pay. And the receiver is the structure, developer. Down here is also the same name, overtime pay, but the receiver is operators. And this is how we calculate overtime rate. And you can see I put something fictitious, is that the operator has an extra 10,000 as bonus because they smile more. This is just come up. But this is how we construct how to calculate overtime pay. And then later on, in the function, we assign Tom as the developer, D. And then as we use this in line 50, we use the overtime pay. We pass the same number of hours and calculate the overtime pay for a developer. And for Jerry, who is an operator. We use the same. If you look at the lines, they are similar. And the overtime pay, it's called the same function, but because of the method, based on the structure and these two different overtime pay, the correct overtime pay is able to be calculated. This is something unique for Go. This is the way something called interface that we should look at, and this is I think worth looking into more than looking into concurrency if we start learning Go, because concurrency is a very advanced feature. If it is not used properly, it might not be able to do its job or what you have expected. So this is something I think this is for the demo. I have a glimpse of what Go is. I started learning Go after Thanksgiving, and it's only a month. I consider myself also a beginner, but this is something I hope I can do some demo on what Go is. Is there any questions on? I don't have Twitter up, or I don't see any questions. Lauren, do we have any question so far?
Not seeing any so far yet.
And this is what I have. And Go resource is what I have here. Is that one thing about Go is that let's say Go playground. Go is that even if you do not load Go into your computer, you can always go here and type in some of the Go code, and it would run for you. Just say if this is the default. If you run, it will say hello world, hello program playground, and this is something you can play around with to check out your code. Let's see. To Google, we use the word Golang is better. Then there's different ways to learn Go, and I hope this can give you some encouragement or some motivation for people to look into this language. And that's all I have tonight.
Awesome job, Anthony. Thank you so much for that.
Thank you. It's a privilege to present a vBrownbag again.
It was definitely a learning experience. I've been hearing so much about Go that it was good to kind of see it. I haven't actually looked into it yet, so definitely a good thing to look into. I hear about it everywhere, so.
Yeah, it's getting more and more popular. And again, just look at this picture. This is my motivation.
All right. Well, thanks to everyone who could join us, and I guess we'll catch everyone next year for the next Commitmas or whatever iteration we call it.
Happy New Year.
Happy New Year.